Okay, good. And let's see if I can share. Good. So I have a presentation which I will make available to you after this talk. And if I'm not sure how many of you maybe give us a sense in the window, in the chat window, how many of you are prepared to actually do some things in R as I'm kind of talking about them. So let me know, maybe drop some yes if you're prepared to work along, and then I can share the code that you're gonna need. So let me see if, yes, so sure I can. Okay, so if you can, I encourage you to follow, and I will share the code in the chat window for you to work with. So here we go. I tried to choose a a catchy title to entice you to attend. Make your R code purr with purr or pure R. Okay, so let me just see page down. Okay, so purr is an R package, for functional programming, and it really relies on this workhorse function called map. Okay, so we'll see how this comes about, and how we use it. But this map function usually requires you to feed to it a vector or a list and a function. So I thought before we jump into how this map function works, I'm going to do a brief recap of, vector, list, functions, and all of that. And I tried my best to come up with some visual imagery that you could relate to understand what's going on. But the whole idea is, we are going to learn more about how this map function works and how you can put it to good use in your own R code. Okay, so what is an R function? Let me just move this a little bit, maybe bring it down here. What is an R function? If you like cooking or baking, the best kind of mental model for an R function, which is one of the ingredients to this pure R or purr map, is a recipe. So with a recipe, when you're baking or when you're cooking something, you do need some input ingredient or ingredients. Then you have to read the recipe, which will give you some detailed instructions for how to use those ingredients to create something you can eat, the output. So for instance, the input ingredient can be an egg. The recipe or the instructions would be you have to break the egg in a pan, you have to have some oil in the pan, fry the egg for 5 minutes, and voila, you have the output. So I find it kind of helps if you have this mental model of what an R function is. So it literally is a sort of generic set of instructions that you can then apply to specific ingredients that you have. And usually our ingredients are data or consist of data, and the output can be anything. It can be another data set that's now processed. It can be a statistical model. It can be a visualization of the data or of the model. You name it. It can be a report, whatever you need it to be. But those are the key components of an R function: the input ingredients, the step-by-step instructions or the recipe for how to use those ingredients to create your output. Okay, now I'm having difficulties changing the slides. Okay, so in R, you will know that there are two types of functions. There are named functions and unnamed functions. The named functions have a name and the unnamed functions don't have a name. So they're also called anonymous functions. To keep things easy in this talk, I will focus exclusively on the named functions, but I think there might be an instance where you will see an unnamed function. And so the named function, you will need a name for it. So make fried egg, for example. Then you need the assignment operator, this arrow pointing to the left. Then you have a keyword function, which you're always going to use to define the function. And then you have the ingredients. For instance, it could be egg, or could have multiple ingredients, egg and cheese and parsley. an onion or whatever. And so multiple ingredients are separated here by commas. Then you need the curly brackets. So these will encompass your instructions, and the instructions are written, line by line, break the egg in the pan, fry the egg for 5 minutes, etc. And then at the end, you return the result, which in this case will be the fried egg. So usually all the functions that are named will be looking like this. When the functions are anonymous, a lot of this goes away, and so you can actually be left just with the curly bracket stuff. But inside the curly bracket stuff, you will need to make some modifications to make sure that anonymous function works. And so when the function has a name, you define it up front, you copy the definition of the function or run it into R, and then you can invoke it every time you need to use that particular recipe on your specific ingredients. If the function is unnamed, you define it on the fly, so to speak. So you define it when you use it. And so the name functions are good if you're going to use them multiple times in your work. The anonymous functions are good if you kind of use them at one time and then you move on and never use those again. Okay, so that's a function. Okay, another ingredient that we have to, or entity we have to worry about when working with purr is a vector. So a vector, really think of it as a cardboard of eggs, which has a single column of eggs. Usually cardboard of eggs come into like with 2 columns of eggs, so to speak. But just imagine this one has a single column, and all the eggs in this column have to be of the same type. So they have to be chicken eggs. You cannot mix eggs of different types, so to speak. Like you can't have chicken and duck eggs and goose eggs or whatever. They have to be of the same type. And so I personally find it useful to think of vectors in R as columns of entities. Those entities, rather than X, they can be numbers, they can be characters, they can be levels of a factor, whatever they need to be. They can be logical values like true or false. But they have to be the exact same thing, like if it's true or false, the entire column contains just true or falses. Good. Now a list is an extension of a vector if you want, but it's literally a hodgepodge of different things you might need to work with, So you can use lists both as a feeding input into your functions, for instance, or as an output storage device. So a function can return different things. It can return a fitted model. It can return the coefficients for that model, the fitted values, the residuals. You combine all of those different quantities into a list, and you return the entire list. So lists are particularly helpful when you define your functions because they will collect all sorts of different entities you need to refer to later, but they're also very handy in the purr world as inputs to your map functions. Okay, let me just check. So Margaret, if you could keep an eye for me on the chat in case there are questions related to the talk.
Yes, will do.
Perfect, thank you. Good, so, okay, so how do all these things, vector lists and functions come together in the purr package? Basically, with this package, you can take any named or unnamed function you might have and apply that to a vector or a list. And so I'll show you some visuals to help you get a flavor for why you would want to do that and what that means. And also, you can save the results using this package in a variety of convenient formats. So you can save the results as a list or as a data frame, etc., or as a table. You're going to see that. So to install the package, if you don't have it installed, the command is install.packages and then in quotes purr with 3 R's. So I'll stop for a second in case you don't have that package installed. You can just try to install it now. So install.packages purr in quotes with 3 R's. Okay, so when do you need purr? So imagine you are in this situation where you need to fry an egg. Okay, so you have the input, which is the raw egg. Then you follow the instructions, you break the egg in a pan and fry it. And then, voila, your fried egg. But what if you have to do this multiple times simultaneously? So you end up not just with 1 fried egg, but with like 3 fried eggs or how many you need. And so you can think of a situation like this where purr would be helpful. So if you need to do something similar, for each column of your data set, for instance, you could use that map function to apply that recipe for what you need to do separately to each column. Or if you have a single column, but for each element of that column in your data set, you need to do the exact same thing. Again, you could use purr. So purr really, like one of the R's, I guess, in there, you could think of it as standing for repetition. So it's very handy when you need to repeat something, but you want to do it in one go. Okay, so you have that recipe. So repetition of a recipe. Now we have 2 R's, repetition of a recipe, and maybe the third is from R itself. That's where purr is handy. You have to define your recipe, like I want to do this to my data. And then you have to repeat that recipe for each, say, column of your data, or it could be each row of your data, or it could be each element of a column or each element of a row, whatever it needs to be. Okay, so let's kind of take a moment to let this sink in. So the 3 R's, maybe we can imagine they stand for repeat recipes in R. Okay, good. So we've seen here an example where all you had was an egg and the recipe was to break it into a pan and fry it, but you had to do that for multiple eggs. So that was one example. But things get more exciting too when you have not just multiple eggs, but you have multiple pieces of cheese to go with each egg. And so you now have to combine each egg with the corresponding piece of cheese and make the omelet. Okay, and then you do the same for the second egg, second piece of cheese, and make the omelet, and so on and so forth. So now you can imagine you're in a situation, perhaps, which I'm not going to demonstrate here, but just as a thought exercise, where you have 2 columns in a data set that you need to combine to create a plot, but then you want to do that combination for pairs of columns. For instance, one variable against time, another variable against time when you plot time series plots, etc. So when you have pairing involved of inputs and you want for each pairing to do something similar, that's where purr again comes in quite handy. So again, you don't just use purr when you want to have, you have a single input and you do something to that input, but you do it a number of times for different instances of that input. You can use purr when you have combinations of input values and you want for each of those combinations to apply a recipe. Okay. And then another example of where you might use purr is where you have, say, this kind of column of inputs, but you're going to combine everything in that column in your recipe to come up with an output. So now you no longer have that kind of parallel thing where each input gets its own output. Now you're combining the inputs first to get sort of single overall output. So that's another example of where purrr would be handy. And so one example of this, for instance, is if you have a column in your data, it might be temperature, and you just want, so each egg would be a temperature record in that column, and you might want to just compute the mean temperature or the average temperature. So that means you're blending all these inputs to get a single output. Whereas here, maybe you have, maybe you have a temperature column, but each temperature, as you are going to see in one example, is in degrees Fahrenheit. And so you want to convert that value into degrees Celsius. So you're going to do, your conversion on a kind of record by record basis. So these are all examples of where you could use input ingredients and a recipe to do something of interest to you. Okay, so as we said, like the function that you're going to write will give you the recipe, then you're going to have the ingredients to which to apply that function, and map will help you sort of map those ingredients to the function repeatedly, if necessary, to get exactly what you need. So map is kind of the connection between your eggs and the omelet, or the eggs and cheese and the omelet. It kind of helps you make that jump between what you put into your code and what comes out of your code at the end of the day. And so I call it the workhorse of the purrr package, or purrr package, because it's kind of the basic function, and then it has a whole bunch of variations that cover specialized cases. But if you understand map, it's kind of easier to understand how you can expand it in different directions to do even more flexible things. So you use map to apply the same operation or recipe, with the operational recipe encapsulated in either a named or unnamed R function, to your input ingredient or ingredients. Okay, so let's see a quick example. And here I will ask you to try this, but I'm just gonna sort of move into this kind of view so I can share the function I have here. So the first example that I have is I will look at the air quality data set, which comes with R, with base R. This air quality has a temp variable expressed in degrees Fahrenheit, and I want to use the purrr functionality to change every single record here from Fahrenheit to degrees Celsius. Okay, now in Canada, we use degrees Celsius. In the US, you would use Fahrenheit. Okay, so if you need to kind of go back to the eggs and fried eggs, raw eggs and fried eggs analogy, your temperature column would be this kind of column of eggs. So a carton of eggs with just one column. To each egg, you're going to apply the transformation in this function, and meaning that you're going to take the temperature record, which in the function is called f, minus 32 multiplied by 5/9, and that will give you the degrees Celsius for that record. So 67 minus 32 multiplied by 5/9 will give you the degrees Celsius temperature for this first record. So let me first give you the function so you have it, and I have to find out where the chat is. So let me know if you could take that function and put it somewhere in a script. So you go to File, New File, our script in RStudio. Oops, sorry. And you put your function here, and maybe you also save the script script, R script for pure R talk. Okay, and once you define the function, you can just run it so that R knows what the function is. You know, you can add a comment here, convert degrees Fahrenheit to degrees Celsius. Okay, assignment operator has the value of temperature in degrees Fahrenheit. Then you have your two curly brackets. I killed the space here just in case R will complain. And then in here, the recipe for how to convert degrees Fahrenheit to degrees Celsius. And here you can just write C to return the value of C, or you could also explicitly write return. Okay, either of those would work. So run. Okay. I always like, after I write my functions, to kind of test them quickly. So for instance, if I put F equals 63 here, I get 17.22 degrees Celsius. Okay, so I test the function to make sure it does what it intends to do. Okay, you can, I shared my testing there, and you can test it with other values. And now you can apply it to a particular column, namely the temperature column, with the map function. So map comes from the purrr package. So this is the syntax: map, and then you feed the column, comma, and then you apply the function. Because remember, hold on, if I can copy this here and move it onto my slide. Remember, maybe move it like this and make it, I have to make it smaller. Okay, hold on, maybe I'll do it like 30. And then move it like this, and then hopefully you can see it. Remember that this map function requires you to give the input ingredient on as the first argument, also called .x. So I could write .x here. And then the function itself is the second ingredient called .f. Okay, so I could write this just as a test for how map works. And I will put this here for you in my chat. Okay, then I'm getting the complaint that, you know, R could not find function map, and that is because I do need to install, like we talked about, which I'm not going to do it now because I already have it. So I need to install that package, and then once it's installed, I need to call it so that R knows what the map function is. Okay, so you do need to have that purrr package loaded in your session. Now, when you look at what comes out, this doesn't actually look very pretty. This is because map always returns a list. So remember, a list is the hodgepodge of things. So in this case, the list has 153 components, okay? And each component stores the value of the original temperature, which was stored in degrees Fahrenheit, but now converted to degrees Celsius. So the first value, for instance, if you scroll up here, is 19.4444. Okay, so, and then the last value here is this. So this doesn't look very pretty, and also is not saved anywhere. When I just call map like this, the result will be forgotten by R as I move on to my next thing. So I will make a point of saving the result and then see if I can actually look at it, make it look prettier. Okay, so I don't have to have these double square brackets, one for each list component or element. Okay, so how do I save the results? Now, the mutate function from the dplyr package, so I'm going to need this package, is very helpful for saving the result. But notice what happens here. I have that correspondence, I have for each record of the temperature variable, I will get a converted temperature in degrees Celsius. So I can use mutate because I can preserve the number of elements in that temperature column in my result. Okay, so I'll have basically a temperature in degrees Celsius that will have the exact same length as the original temperature value. And because of that, mutate will help me append this new variable temp C to the original data set. Okay, so when I mutate with this dplyr function and create the temp C variable as a call to map applied to the temperature, original temperature variable, and where I use this F2C recipe for my conversion, I will get temp C as a new variable. Okay, this actually threw me off into a loop, understanding like when I can combine map with mutate. So I can do that combining as long as I am in this type of situation where each input gets its own output. If I'm in a situation where I sort of break all the eggs into a bowl and make a single omelet, then I don't need to use mutate because the result will have a totally different dimension than the input. Okay, so keep that in mind. That's kind of handy to have clear. So let me send you this code so you can try. Hold on. Okay. So as long as your F2C function returns or performs an operation or a recipe that gives you a single value for each record of temperature, you're safe to use mutate in your code. So let me just put this here. Okay, and if I run this, okay, you're gonna see, and this is a bit hard to see, so I have to keep scrolling back up. You're gonna see that temp C is now a list. Remember, map always returns a list. Okay, so a list means, an entity which has different compartments, one for each converted temperature record. And you see these compartments with the $ listed here. I find like one kind of handy way to think about these lists. It's almost like because we're talking about the ingredients, let's think about them as cupboards. Okay, so you kind of think, let me see if I can do the drawing. You think that you have this cupboard, and then the cupboard has different sort of drawers. Okay, and in each drawer you're going to put a temperature record. Okay, and so each temperature value you have in that data set will receive its own drawer, but that that can be a little bit of a pain. So as you see here, like it does make the structure of the data set uglier and so on. And so one handy trick you can use is to actually unlist this so that all the records are held together in one place. So when you unlist, these dividers disappear and the whole thing is in one big compartment. Okay. The whole thing meaning the converted temperature record. And so you can unlist by just tagging another unlist call after mutate. So here you could come here and then just put temp C equals unlist temp C. Okay, you can just do something like that. And then let's see, I'm just going to execute this to see what happens. Oops, again, for me to execute all of this, I will need two packages, magritte R, which is the package from which the pipe operator comes, and then library dplyr for the mutate function. Remember, the pipe means and then, so take the air quality data set and then mutate or create a new variable called temp C by applying the conversion of Fahrenheit to Celsius to each record or row in the temp column. Okay, so now if I do this, and then I can add, you've seen that list, and then I can add the unlist command here. Then things will look much better. You can see now temp C becomes itself just a numeric vector. In other words, a single column which will contain all these converted temperature values. Okay, and so it's handy, rather than kind of have these two distinct operations, it's handy to combine this map with unlist via a function called map dbl. DBL is shortcut for double. Okay, and double is basically the same as numeric. So for all we care, this could have been called map underscore num, but it's called map underscore DBL instead. And when you use that one-step process, if you know that you're going to return for each temperature record a numeric or equivalently a double value, you can just put map DBL here. Okay, and then you get directly that nice numeric column. Okay, so I'm just gonna, hold on, I do see a question there. Hold on, I just share my code and I'll stop to take this. If I can see, what is the additional advantage of the map function in this particular case? No, so there is no advantage. This is like the simplest of cases. So this would work directly, but then as things start getting complicated, there will be an advantage that's visible. So this is just to show you, you know, the kind of simplest capability of map. But there are other fancier capabilities. Okay. So I've already explained, I've already explained the map double as a specialized version of map. Now I'm going to give you a more complicated, slightly more complicated example where you're going to use map not on a single column to affect what happens to each element in that column, but use map on a set of multiple columns in a data set. And so the function that we're going to use here, I'm just going to call this function my mean because it's basically defined to, by default, remove the missing values in a column before it computes the mean. So I'm going to give you the function here. Okay, and then let's see how we apply it. So first we are going to select just the variables that are relevant from our data set, which are ozone through temperature. We do the selection with the select function in dplyr, and then we're going to use map, but remember outside of mutate now. to apply this my mean function. And I think this would probably work even if you take this dot out. So the dot means whatever data is flowing into here from above the pipe, apply your my mean function to each column of that data set. So I'll give you the function here. Okay, and you can play with that. And then try to remove the dot as well and see if that works. And of course, applying the map function with my mean here will return a list. If you don't like that, you can use map_dbl, or you could just unlist the results. So you would put here unlist at the end. Okay, but this is an example of where I'm applying map, but I don't need mutate anymore, because now the results that I get are basically 4 numbers. So they no longer match the dimension of my selected data. And the selected data would basically contain just the 4 variables, ozone. Let's put the head so you see here. Ozone, solar radiation, wind, and temperature that I'm selecting. So I'm going to get the mean for each of these 4, but therefore 4 numbers, but there's no more correspondence anymore between these 4 numbers and the dimension of the original data set. So for that reason, map is applied outside of mutate. Okay, so again, this is an example where each column whose mean you're computing is basically like a column of eggs. And for each column, you're going to build or apply a recipe to get your omelet, which in this case is the mean of that column. Okay. What other flavors of map are available? If you know what you're returning, whether it's a logical value or a column of logical values, an integer value or a column of integer values, a double or numeric or a character, you have that variation of map. So which would essentially allow you to forego using map plus unlist. Now, what's interesting is that there are other variations of map, like map2, where you would have 2 sort of input columns or 2 input data sets or 2 input lists or whatever they are, to which you would combine together and then apply your recipe to. So and then of course there's extensions or generalizations from 2 to more than 2 through the so-called pmap function, okay, which I'm not going to cover here. So an example of map2 and plotting is when you say you want to construct a plot for every column of your data set that is relevant. Like for the temperature column, you want to construct the histogram. For the ozone column, you want to construct the histogram, etc. So you're going to define your function, and I'm going to give you, okay, it works without the dot too, says Margaret. Great. So you don't actually need that dot. If you are lazy typer like me, you take that out. Okay, thanks for checking that, Margaret. Okay, so here's a histogram function. So now you have 2 ingredients here. Think about, the eggs, one like column of ingredients, and the cheese. And then you make a cheese omelet, by combining all the eggs and all the cheese together. That's basically the mental model. And so here's the histogram function. You are going to have a data input, and then the variable from that data set for which the histogram will be conducted. Then I sort of added my libraries that I need inside the function here. and I'm using ggplot to plot the data. With ggplot functions and dplyr functions as well, you do have to be careful how you're feeding your data and variable here. So the data just listed here, but the variable, it, for instance, can be specified like dot data and then in square brackets, the variable. Okay, and then if you had another variable here like var2, your y would be dot data, square brackets, var2, etc. And so there's your function. And then how do you use this version of map2 to plot the histogram of each of the ozone through temperature columns? First, it helps if you're going to select just those columns from the data. So we're using the select function from dplyr to do that selection. Let me just show you again the head of the selected columns. So you just have these 4 columns. And now for each of these, you want to apply that histogram. But that's why you needed that var there, because repeatedly var will be set to ozone or solar.r or wind or temp. Okay, so the data set won't change, but what changes within the data set is that variable that you're going to pull out. And so I'm going to give you the code and then explain very quickly how that works. Okay, so once you have your columns that you're interested in, okay, you have to list the columns and feed that list as your .x argument. So these are the columns that of the data that you're going to apply the histogram to. And then in your .y argument, you're going to give the names of those columns. So those are your variables. So this here is the equivalent of the data in your histogram function, and this is the equivalent of the variables. And so the data, so now there will be like a combination of the data, which doesn't change. It will always be the same with each of the variables listed here. So the names, if I show you the names, would be ozone, solar radiation, wind, and temp. So you're going to combine the data with ozone, the data with solar radiation, the data with wind and temp. And through this histogram function, remember, has a data argument. So let's show you a different color, and then a var argument. Okay, and it didn't read, so I sort of, I was careful to specify the data first and then the names of the variables that would go here. But I think you can try like what happens if you swap, maybe map2 won't care, or maybe it will. So don't be afraid to try. And so here's the histogram function used. And then it turns out that that code, this code here, histograms, will basically, let's see if I can run it here. It will basically return a list of histograms, okay, which you can actually see here in your plots window if you sort of go through them. But it's possible to wrap those plots with wrap plots from Patchwork and control the layout of the plots. So I gave you this. I think I need to give you this. So you can control the end call, or you can change the end row. Okay, I need the library Patchwork. So for any package that you need, you would have to install that. So here I can control the layout by changing end call to end row and showing all my histograms there. Remember, if you need to install a package, install .packages Patchwork. Okay, Margaret, let me know, how am I doing for time? How much longer can I?
Oh, I guess maybe 10 minutes or so. I don't know. What do you want to do? I don't know if people can stay on. I mean, it's 7 minutes before the hour, but
Okay.
I mean, I think this is really useful. So
Okay, so I'll cut me off, cut me off when you need to cut me off. Someone said gorgeous. I wasn't sure about what. The plots. Maybe the plots. The plots always look fun. Okay, so and it's possible, like maybe after this, I'll share another example where you see how we can use two input variables, not just ozone, but say maybe you want to plot ozone versus time, and then solar radiation versus time, and you pull those from the same data set. So I'll try to share one of those. Yeah, gorgeous. Yes, everything. Oh, that's so sweet. Okay. Now, so we've seen kind of map, useful to apply a recipe to either each element of a column, which is like a simplistic case, or to each column in a data set. But where map is kind of really cool is it.
sorry, Isabella, I'm sorry to interrupt, but there was a question about on the previous example, why you needed to have the call to list around air quality.
Let's see. So remember, my philosophy is it never hurts to try things out, like, oh, will this work without that? I remember like in teaching a previous course that I had struggled for hours getting errors, and then I discovered I have to list that, which seemed counterintuitive. But let's see. Yeah, you see, like I still get the plots, but I do get this error in Fortify. Data must be a data frame or other object coercible by Fortify. And so, and I don't know, like, hold on, because I already had my histograms there from the previous, sorry, histograms. Okay, so now actually I'm not creating anything if I don't have that list. So, it's one of those quirky things that I had to spend hours to figure out. This is not very intuitive, but if I don't put this here, my plot will throw errors, and my plotting code will throw errors. So don't ask me why. Like R is full of programming inconsistencies. You just have to spend some time to figure out what works eventually. So it's like brute force, calculation or hack or whatever. Okay, now, so that kind of gave you a sense of how map can work. And now what's really cool is when you're introducing some level of grouping in your data set, and then you can apply your recipe to each column of subgroup of your data set, and then move on to the next subgroup and apply the recipe there, etc. So that is very nice. And can come in really handy. So let's see, like if you haven't seen these nested data frames, which I actually don't work with that much myself either, but now I'm falling in love with them, that I have to teach you about them. Here's how you get a nested data set. So you're going to need the tidyr package and the nest function from the tidyr package. So let me give you the code first. There was another question. Hold on. It's a bit hard to like scroll up at the top.
It was just a follow-up on the other one. It's true that air quality num was a data frame. So like
it is true.
That it's just a little puzzling.
Yeah, it's just like I said, a programming inconsistency of which R is full. Trust me. So don't waste your time railing against the machine. I've done it and it doesn't lead anywhere productive. So okay, so where was I? Okay, so you have your air quality data set, and this data set includes ozone, temperature, etc. records, daily records for each month from month labeled 5, which I believe is May, through 9, which is September, in New York City in 1973. So this is quite an old data set. But anyway, it's one of the teaching data sets. And so what if you want to do certain things, apply certain recipes to each month? Okay, you could take your air quality data set group by month. And if you have other sort of things like site, you just put a comma site there. Okay, so group by month and then nest and save the result as a so-called nested data frame. And so here's what the nested data frame would look like. You have each month, so that's the grouping variable. And then the data is actually hidden inside this list column. It's called a list column, which contains a whole bunch of tables. So tables are basically fancy data frames. They have better printing properties, but they can also be used to append different things to, as columns in those tables. So you could append actually another data set in each row of a table or whatever, so that they're much more flexible than data frames. Okay, so once you nested your data set so that each group receives its own kind of portion of that data set, or each month in our case, game on. You can start applying your recipes with purrr as much, as fancy as you want. So for instance, as a quick example, what if you need to compute the mean of the ozone variable for each month present in the data? Okay, so basically you're going to have to go to this table, compute the mean of ozone here for month 5, then move on to 6, 7, 8, and 9. And so again, you're repeating this recipe for computing the month mean level of ozone, monthly mean level of ozone for each month. And so you need to define your recipe first through the function that you're going to use. Is there a difference? There is a difference between nesting and splitting, because when you're nesting, you end up with the so-called nested data frame. When you're splitting, is just a list of data frames, so it's kind of different. But I mean, you could use similar principles, I guess. I can sort of look at putting together an example for afterwards of using map with the splitting by month rather than nesting. Okay, so here's your recipe. Again, like what helped here is I'm gonna define a function of the data, and then I'm gonna select just the variable that I need from that data and use the summarize function from dplyr to compute the mean, and then just return the number. So that's why I'm using this pull to return the actual number, which is the mean ozone. And so if my function returns a single number, and I know that number will be numeric, my best bet is to sort of use map double. So, remember, when I defined my nested data set, my data column includes all the data sets for each month. And so when I use map double, the .x argument here is the data column of that nested data frame, and .f argument, which is the function, is my compute mean ozone function. And so once I do this, I forgot what I shared, but anyway, once I do this, I'm good to go. Okay, and then I do use mutate there because each of these months will get its own result. And so with mutate, like I have that same kind of dimensionality match between my results and the dimension of the data. If I didn't care about adding my my results here as another column, I wouldn't need to use mutate there. And so you'll see here, once you apply your recipe to the data column from that air quality nest, and you save the result as say mean ozone, you see that nice column. And so from here on, because this is literally, it is a nested data frame, but it's also a data frame. You could plot, say, these mean ozone values the way you would plot them normally. The way I would do it is just create a date variable with the year and the actual month and the fake day, like first day of the month, and then plot mean ozone versus month, as you see here with the trimmings that you need. But once it is a nested data frame, it's also a data frame. So that mean ozone column treated the way you would any column in a data frame. Now, of course, you can compute multiple functions for each of those nested data sets, like the mean and median. Again, your function recipe, compute the mean, median of ozone, put data as your input, and then select ozone, and then with summarize, compute the functions that you need. And then again, you mutate, call this ozone descriptives or whatever you want to call it, and it's a map on the data column of your nested data set where you're mapping to each element of that column this function. So that's all it takes. So now it's just a matter of, I'm going to share this, just a matter of figuring out how to write this function, to get nice results out of it. And so you see the results here come out as a table, which you can then go into and access as shown here. So let me just, so here I'm accessing just the first table and so on. And it is possible to unnest this if you wanted to unnest. There's an unnest function you could apply to ozone descriptives.
Isabella, I think Janelle, you have a question?
Yeah, go for it. I'm not seeing it.
Sorry, I didn't write the question in the chat, but it was, I was curious, maybe it's because it's a nested data frame, but I was thinking that one could use that unlist function. But it seems as though when you pulled out the descriptive for the ozone, then you got, these are two column variables now, mean ozone and
yeah, and you have control how you want to return these, you know what I mean? So like if you want to return this as mean on one row and median on another, so just write your function to do that. So you can make your function return a particular results in a particular way, and then that's exactly what you're going to save. So you have full control. Here I'm just kind of showing you that all you need is literally your data as an input, and then the output, it can be stored in any way that's convenient to you. Okay, so you have the output doesn't have to be a single number. It can be numbers listed in a column, in rows, in whatever, as a table, as a data frame, however you want to put it. It doesn't really matter. Okay, whatever it's comfortable for you. Now, of course, just to finish with the map on nested data frames, what if you have to use more than one variable in your computation? Let's say compute the mean of the ozone through the temperature variables. All you have to do is to kind of get smart about the summarize function, because it does come with a summarize at version, and you choose your vars, your variables here inside the first argument of summarize at, and then the function you're applying goes here, and then any options for the mean function like ni.rm equals true go after the mean. So, but here what helps too is you can, and this journal might come in handy for you, you can use other flavors of map. Like instead of map, you can use map_df, which will return a data frame. Okay, so let's see what happens when you do that. So you can also get creative with, am I going to use map? Am I going to use map df? There's also a map dfr for binding results by row, etc. So you do have lots of options there. So here's what happens here, like where you get basically the results stored as a list, mean with the ozone, solar radiation, wind, and temperature as the components of that list. And you could, like I said, unnest. Let me try to run this to see if I can unnest here. So if let's try this. So if you can see, like, it's always good after you use this to look at the structure, which can be quite complicated, but you see here the mean is a table with all this information, etc. For each month. But then, like, if I put, let's try maybe an unnest here on the mean. Yeah, remember I need unnest and nest come from tidyr, library tidyr.
I think you're missing the an extra n in the unnest function.
Ah, yeah, that's right. Let's see. Okay, so if I do this, just come with that unnest command at the end there and just apply that to the mean. If I do the structure, let's see what happens. So now this is stored differently, like it's still like a table and so on, but it probably would look different if I do this. And if, who knows, like, if it has an effect or not. It's just a matter of like trying different things and seeing what looks best. Okay, so now it actually gives me columns for each of those summary statistics called ozone, solar radiation, wind, and temperature, etc. So that's kind of nice. When you unnest, you get the results to look a little bit more explicit rather than hidden inside a table type of thing. Okay, good. So the last thing
Probably
here.
we should kind of wrap up.
Okay, good. So anyway,
I don't know, or if I guess people could kind of decide.
Yeah,
but,
good. So just one last thing. Can you fit models? So I'm just going to talk about this slide just so that you know. Can you fit models to nested data frames? Yes, you can. Just write your recipe for the model, feed the data, fit your models in there with the variables you care about, like say a linear model of ozone versus temperature or whatever, if it needs to be, and use your mutate to define a model column in your nested data frame, which will map the data to this recipe for fitting the model. It's really as simple as that. The model will be put here as an additional column. You can output any model you want. I show here how you output the first model, and you can further process the each model in that column with functions like tidy from broomr. And this is the first and only place you're going to see a so-called anonymous function in R, which is defined on the fly. I don't have this function defined up ahead. And with the anonymous function, you need a tilde, then the function name, and then the argument will, which is literally a model, is called .x here. And if you have multiple arguments, you might use .y if you have two arguments, or .1, .2, .3 if you have three, etc. So yeah, that's it. It can do more processing, etc. And there's some other stuff that I share in the slides where you, once I share the slides, you can play with that as well. And finally, my favorite resource really for purrr was this functional programming. No, sorry, not this. Yeah, this functional programming here, and it's really, really nice. So I'll drop this here as well with a nice kind of, visualizations to help you understand what inputs are mapped and what outputs come out. So I'll stop here. And I did mention to Margaret, like if there's any interest in learning more about the anonymous functions in this context of purrr, I could always come back at some later point and talk about those too. Perfect. So thank you. Any burning questions before you all scatter away?
Let's all thank her. I think that was a really wonderful presentation. And I'm really looking forward to looking at the slides too. I'm sorry that we're a little bit out of time, but we'll post those slides for everybody to be able to play around with those further examples. I think that it's really cool to see. I think, like I've said, I'm an old school R programmer who learned, to write lapply and sapply and, mapply and all those apply functions.
Yeah.
And so I think that the power here is just the integration with the tidyverse stuff and like getting output that's actually more functional and easier to use. And, I think that that's really useful, and all those kind of extra functions that they've written for doing those kinds of things as well. So I think that'll be really nice.
Yeah, so I'll email the slides right away to you, Margaret, after we finish here. I'm just kind of chuckling because some of the participants were so nice and they were like, I could do with another 1,000 hours of this, or so that, or like I could listen to Isabella for hours, which is nice to know because usually nobody listens to me.
Oh no, thank you so much, and thanks for all the positive feedback, everyone. If there are any more questions, we have a few more minutes on the Zoom. If you want to ask anything, certainly you should feel free.
Yeah, I would say, as I was telling you, Margaret, I found it a bit hard to wrap my head around this map function, because it can be used like in so many contexts. But there's a lot out online. So just Google.
I know. I swear that when I'm teaching my students a program in R, I'm really teaching them how to Google.
Yeah, I know.
Again, like it's the same thing. Like I said, I learned so many years ago, all this stuff is new for me. It's not like I remember all the syntax for everything. It's all about knowing how to ask the question so that you can get the answer, see the examples, manipulate them, get them to do what I think.
Try yourself, things. And, I can tell you, I spent a few hours trying things that did not work. I still have things, where like I never did get them to work. So, this stuff is not easy. That's why I sort of showed you how to write your own recipe, because then you can test, like if you have the function named, you can test that for some cases, and then put it in your purrr kind of context. But yeah, like with the anonymous functions, I think you really have to be sure they work as advertised. It's much harder to debug those. So, use those for simple things if you can. I do have a handout on anonymous functions, so I'll circulate that too if I can retrieve it.
I'll make sure to include those so people will have access to them. Are there any remaining questions from the group for Isabella before I stop the recording? All right.